in the middle of a massive music festival.
Oh, yeah. Best feeling in the world.
Right. The bass is just pounding in your chest, the synthesizers are swirling all around your head, and the acoustic space feels absolutely colossal.
Like you're standing in a massive cavern.
Exactly. Your brain is totally convinced you are standing in this vibrating, cavernous room, or like an endless echoing canyon, but you aren't. Your brain is being actively tricked.
Very actively tricked.
Yeah, and it's being tricked by a single piece of software from 2006.
It is honestly a remarkable illusion. I mean, in an industry where software updates happen weekly, and plugins become obsolete in a matter of months.
Oh, yeah, constantly.
A nearly 2-decade-old tool is still the foundational architecture of the modern dance floor.
And that is exactly the premise of our deep dive today. We are unpacking this extensive 6-episode research notebook compiled by 786 Music, LLC.
It's a fantastic source, really thorough.
It really is. And according to their research, if you want to understand the three-dimensional space of modern techno and tech house, you have to understand one specific tool, Soundtoy's Echo Boy.
Yep, that's the one.
So our mission for you today is to explore the fundamental difference between mechanical repetition and the art of creating true, immersive acoustic space. Okay, let's unpack this.
Let's do it.
Generic digital delay is basically like reading a perfectly typed transcript of a conversation. It tells you exactly what the words were, repeating the audio signal flawlessly.
Right, but it's just the words.
Exactly. But Echo Boy is like hearing the actual voice, complete with the breath, the warmth, the slight hesitation, and the raw emotion.
I mean, think about what happens when your ear encounters that perfect transcript of an audio signal.
It sounds kind of dead, right?
Completely. Traditional delays just repeat a sound, and because it is a mathematically pristine copy, your brain instantly flags it as artificial. It just sounds sterile.
Like a machine.
Right. But Echo Boy's entire design philosophy runs in the complete opposite direction. It mathematically models how real physical devices break down.
How they degrade the sound over time.
Exactly. When a sound degrades through a physical space or through analog circuitry, it feels lived in. It tricks your primal hearing mechanisms into believing the space is genuine.
So to understand why a modern, cutting-edge digital plugin intentionally goes out of its way to destroy your pristine audio, we actually have to get into a time machine.
A very cool time machine.
Yeah. We need to look back at the history of how humans first tried to create echoes artificially.
And, the evolution of those early machines is the entire reason Echo Boy even exists. If we look back at the 1950s and 60s, we're looking at the tape echo era.
Right, the golden age of tape.
Yeah. Audio engineers started out by taking massive Ampex 200A magnetic tape recorders, machines the size of refrigerators meant just for recording and playback.
And they literally hacked them, right?
They did. They would feed an audio signal into the tape and then read it back a fraction of a second later using a secondary playback head.
Which is just brilliant.
It was. And this physical hack eventually led to purpose-built portable machines. You had the legendary Maestro Echoplex EP3 in 1959.
Oh, classic.
Yeah, which used a rotating magnetic drum. And later you had the Roland Space Echo RE201 in the 70s, which used physical, continuously running loops of magnetic tape.
And those machines are still considered the holy grail of audio texture today. You see them sitting in top-tier studios right now.
Absolutely. They are highly sought after.
But reading the 786 music notes, the magic wasn't in their pristine quality. It was actually all about their flaws.
They were beautifully flawed. When you record audio to physical magnetic tape, you inherently alter the sound. You get tape saturation.
Which kind of squashes it a bit, right?
Right. It naturally compresses the sound and adds harmonic richness.
Yeah.
You also lose high-frequency crispness the longer the echo repeats. But the most defining characteristic was something audio engineers call wow and flutter.
I always laugh at that term. Wow and flutter. It sounds like a magic trick.
It does.
But the mechanics behind it are fascinating.
Yeah.
And flutter basically refers to the natural wobble caused by the physical motors that drove the tape.
Right, because the mechanical motors couldn't maintain an absolutely perfect microsecond consistent speed.
Exactly. So the tape would speed up and slow down by these microscopic fractions. And those mechanical imperfections caused tiny pitch variations in the delayed signal.
Yeah.
Your echo would slightly bend in pitch.
And to the human ear, that wobble sounds incredibly musical. It adds life to a totally static sound.
Yeah. So then moving into the 1970s, technology shifted from tape to the bucket brigade era.
Yes. This gave us iconic analog guitar pedals like the Boss DM2 and the Electro-Harmonix Memory Man. They were smaller, much more reliable, and just immensely popular.
I have to pause on the name Bucket Brigade, though, because the 786 music source highlights this architecture, and the mechanism is just brilliant. Why is an electronic circuit named after a 19th century firefighting tactic?
Because that is literally how the circuit processes the audio signal.
Wait, really? Like passing buckets?
Seriously. Inside those analog delay pedals are a series of tiny capacitors. Imagine a line of firefighters passing actual buckets of water down a line to put out a fire. The audio signal is the water.
Okay.
It gets passed from one capacitor to the next to delay the time it takes to reach the output. But just like passing buckets of water, with every single handoff, a tiny bit of the water spills out.
And the high frequencies spill out.
Exactly. With every pass through the capacitor chain, the high-frequency water is lost. So it results in a delay that gets progressively darker, murkier, and warmer with every single repeat.
Which is why it sits beautifully behind the lead vocal or synthesizer.
Right, because it doesn't compete for the bright, high-frequency space.
Okay, so we have warm tape and murky buckets.
Yeah.
But then the 1980s happen and the digital revolution arrives.
The game changer.
Right. We get hardware like the Lexicon Primetime in 1978. This was a true digital delay. It was hyper clear, had absolutely zero artifacts, no wobble, and no spilled water.
And it cost thousands of dollars.
Thousands. But wait, if the Lexicon was mathematically perfect and had no noise, why didn't producers just stick with that? Like, why did early digital delays get a reputation for sounding terrible?
What's fascinating here is that the perfection itself was the trap. Ultra-expensive units like the Lexicon were engineering marvels, sure, but they sounded completely unnatural to the human ear.
They were too clean.
Exactly. Meanwhile, the early affordable consumer digital delays that flooded the market, they lacked processing power. They used poor algorithms to copy the audio, so they sounded brittle, grainy, and metallic.
Gross.
Yeah. What the industry slowly realized was that tape and bucket brigade delays sounded musical by accident.
Wow.
The physical limitations of those analog circuits inadvertently created the exact warmth and pitch modulation that human psychology actually craves.
They couldn't make a perfect copy even if they tried, and that limitation became the secret sauce. Which brings us right back to Echo Boy.
Full circle.
Yeah. When Sound Toys released it, they didn't just write code for a generic digital delay. They built a library of ghosts. They painstakingly modeled the circuitry, the flaws, the hisses, the spilled water, and the tape wobbles of 30 distinct vintage echo machines.
They turned the mechanical bugs of the 1950s and 70s into intentional digital features. You were essentially dialing up the soul of a vintage machine inside a modern computer.
That is just so cool. Let's pivot to how we actually use these ghosts.
Yeah.
Because the 786 Music Notebook explicitly links this vintage modeling technology to modern dance music, specifically techno and tech house.
Right.
To understand that, we have to look at the rhythm controls, the groove, feel, and accent.
Because these rhythm parameters are what separate a static mix from a truly hypnotic groove. They dictate exactly how the delayed signal interacts with the foundational beat of the track.
The groove control is especially interesting to me. It adjusts when the delay repeats happen relative to the absolute mathematical grid of the computer.
Right, the timeline.
Yeah. If you set it to 0%, it is completely metronomic. It hits exactly on the grid. If you push it to a positive percentage, it rushes the beat. The echo hits a fraction of a millisecond early.
Pushing the energy forward.
Exactly. And if you dial it to a negative percentage, it drags slightly behind the beat. But here's my confusion. Techno is entirely built on a driving, locked-in grid. The kick drum is basically a metronome.
It is.
So if I intentionally dial in a negative 5% groove to drag the echo off the beat, won't it just sound like the drummer is sloppy and out of time?
You would think so. But the psychoacoustics of how our brains process rhythm tells a completely different story. The phenomenon is called habituation.
Habituation.
Yeah. If every single element in a track hits at the exact mathematical millisecond over and over again, the human brain essentially gets bored. It predicts the pattern perfectly, decides there is no new information to process, and it just tunes out to save energy.
So it basically stops actively listening.
Precisely. Electronic music is made on highly precise computers, which means it desperately needs microscopic human inconsistencies to force the brain to keep paying attention.
That makes so much sense.
Yeah, so a negative 5% drag on an echo creates a dreamy, laid-back, deep techno vibe. It creates this micro-tension that pulls the listener deeper into the groove.
And conversely, a positive 5% push creates urgency, right?
Exactly. The echo arrives just before you expect it, which adds forward momentum. It's perfect for bright, high-energy tech house.
And the 786 Music Notebook actually gives us specific recipes for applying this, which I love.
Yeah.
You aren't just picking a random delay, you are casting actors for different roles in the mix.
That's a great way to put it, casting actors.
Yeah. For instance, if you are mixing synthesizers, the go-to model is the Electro-Harmonix Memory Man. You set it to a quarter-note delay, and you add a CE1 chorus effect.
And a chorus effect is crucial here. It clones the audio signal, slightly detunes the pitch, and delays it by just a few milliseconds.
It literally turns a single synthetic voice into a wide, thick choir, giving the synth an incredibly warm character.
Then you look at the pads, those long, sustained, atmospheric background chords. You cast a different actor. You switch the Echo Boy model to the Roland Space Echo.
Right.
You set the delay much slower, to a half note, with a long feedback tail. And you heavily lean into that signature tape, wow, and flutter. The pitch bending creates this massive sense of sweeping space without clashing with the lead instruments.
But for the drums, it's a completely different approach. You cast the Boss DM2, you want the rhythm clean and tight, you set a fast 16th note delay with a very short tail.
And here's the rule. You absolutely turn off all modulation. Zero wobble on the drums.
Oh, really? None at all?
None. If the pitch of your kick or snare echo starts bending, you introduce phase cancellation and the entire low end of your mix just turns into undefined mud.
Yokes. Nobody wants muddy drums.
Exactly. And this introduces the biggest challenge facing a producer. If the whole goal is to make these echoes invisible, to literally trick the ear into just feeling a bigger room, how do we shape these massive echoes so they don't turn the track into a muddy mess?
Right. To pull that off, we have to look at tone sculpting. The source material spends a lot of time on saturation versus distortion, because they are absolutely not the same thing.
They are definitely not. The distinction between the two is the difference between an amateur mix and a professional master.
Okay, here's where it gets really interesting. Let's look at the mechanism of what these two controls are actually doing to the audio waveform. Think of saturation, which you can dial up in Echo Boy to add tape-like compression, as adding heavy cream to a sauce.
Oh, I like that.
When you add saturation, you are generating warm, harmonic frequencies that naturally blend with the fundamental sound. It fills in the acoustic gaps and makes the audio waveform thicker and rounder.
Letting the sauce simmer so the flavors melt together.
Yes. Distortion, on the other hand, is like taking a jagged knife to the waveform. It literally chops the peaks off the audio signal. It introduces non-harmonic artifacts.
It's like throwing a handful of raw chili flakes into a dish. It adds a harsh, aggressive crunch. You only want distortion if you are intentionally trying to give a sound a violent bite.
Right. For standard tech house depth, you keep distortion at 0 and push saturation to a 2 or 3 to get that thick, creamy warmth.
And once you have that warmth, you have to control its footprint in the mix. This is where the high-cut filter becomes an absolute necessity.
Okay.
A high-cut filter literally rolls off the high-frequency treble of the delayed signal. The 786 Music Notebook recommends a 25 to 50% cut.
So just chopping off the high end. But wait, why do we want our echo to sound muffled?
Because it is an evolutionary hack. Our auditory systems evolved over millions of years to assess our environment.
Right, survival instincts.
Exactly. If our ancestors were standing in a forest or a cave, they gauged the size of that space by how sound bounced off the walls. High-frequency sound waves carry less physical energy, so they get absorbed by the air and the walls much faster than low-frequency sounds.
Oh, wow.
Yeah. Therefore, in the real world, the longer an echo travels, the darker and more muffled it gets. By aggressively cutting the highs in Echo Boy, you are mimicking natural physics. You are tricking the listener's primal spatial awareness.
That is wild.
Furthermore, from a mixing standpoint, cutting those highs keeps the echo from clashing with the bright, modern elements that need to sit at the front of the track, like the lead vocals or the hi-hats.
It naturally pushes the echo into the background. And that leads to 786 Music's golden rule, the invisible effect principle. Echo should be felt, not heard.
Felt, not heard. It's so important.
They recommend a very specific bypass test. If you are mixing a drum loop and you bypass the Echo Boy plugin, the drums should suddenly sound a bit cleaner, but the physical room should instantly feel like it shrank.
It should feel uncomfortably small.
Yeah, if you achieve that, you've nailed it. If you turn the plugin on and you immediately hear an obvious repeating tail, you've used way too much. It's supposed to be acoustic glue, not a spotlight.
It creates the environment, it doesn't take the stage.
But this raises a huge question. We are keeping it subtle, we are hiding it in plain sight, ensuring the room feels natural.
Right.
But what happens when a DJ is playing a massive 50,000 person festival and they need to build an unbelievable amount of complex tension right before the beat drops? How do producers get away with creating those massive chaotic stadium buildups without completely ruining the mix?
That requires moving away from basic delay theory and stepping into advanced signal architectures.
This is where I totally want to geek out over rhythm echo mode. This specific feature completely separates Echo Boy from a generic delay pedal.
It really does.
In this mode, you aren't just telling the software to repeat a sound every quarter note, you are presented with a timeline graph. And you can plot up to 16 individual delay taps wherever you want. You can literally compose a polyrhythm.
Which completely changes the nature of the effect. If we connect this to the bigger picture, you are no longer just delaying a sound. You are composing an entirely new rhythmic texture.
The source outlines a great workflow for this. You set your main echo tap to hit on the standard quarter note. Then you plot a secondary tap on the eighth note just to fill in the rhythmic gaps.
Okay.
Then, and this is where it gets crazy, you plot a 16th note triplet. A triplet in a standard 44 dance track creates this rolling, complex counter rhythm. Finally, you add a long half-note tap for a spacious tail.
So to the listener on the dance floor, it doesn't sound like a simple echo anymore. It sounds like multiple, incredibly sophisticated delays cascading over each other.
Yeah.
And the true art form is how producers automate this polyrhythm during a buildup. During the first few bars of an 8-bar rise, the echo mix is practically invisible, sitting around 20%.
Barely there.
Right. But as the snare drum starts rolling faster and the tension builds, the producer uses automation to slowly turn the mix knob up. 30%, then 40%.
Oh, no.
They simultaneously increase the feedback, which means the polyrhythm repeats longer and longer, washing out the entire track in a chaotic wall of sound.
The tension just reaches a boiling point. And then right on the exact downbeat of the drop boom, they instantly automate the echo mix all the way back down to 15% and kill the feedback entirely.
The psychological impact of that contrast is staggering. The massive chaotic stadium space instantly vanishes, and the listener is slammed with a tight, dry, punchy kick drum. The drop hits exponentially harder precisely because of the immense space that was just ripped away.
But managing all these complex swirling echoes requires a very specific technical workflow.
It does. It can get messy fast.
Yeah. The 786 music document reveals how professionals actually route this inside software like Logic Pro or Ableton, because you do not just drag and drop an Echo Boy plugin onto every single instrument track in your session.
Definitely not. Doing that would not only destroy your computer's CPU processing power, it would create a totally disjointed mix. Instead of plugging every instrument directly into its own delay, which is known as serial processing professionals, build an auxiliary send network, which is parallel processing.
Let's walk through exactly how that works because it's a game changer. Imagine a digital mixing board. Instead of putting the effect on the vocal track, you create a brand new empty track, an auxiliary track.
Right.
You load up one instance of Echo Boy on that R track, let's say with a warm Echoplex tape model, and you set the plugin mix to 100% fully wet.
Then the magic happens in the routing. You take your lead synthesizer and you simply send a copy of its signal to that auxiliary track. You take your drum bus and you send a tiny copy of it to that same O track. You do the same for the vocal.
So a single instance of Echo Boy is processing multiple instruments at the exact same time. It is highly efficient for the computer, but more importantly, it glues the track together psychologically because the synth, the drums, and the vocals were all being processed by the exact same, flutter and tape saturation. The listener's brain is convinced that all of those disparate elements were recorded in the exact same physical room.
It creates extreme cohesion, and elite producers take this parallel processing even further by building a frequency-stratified mix.
Wait, stratified?
Yeah, they don't just use one room, they use frequency-specific environments. They will set up one auxiliary track with a warm, murky Echoplex model specifically tuned for the low-end bass and low synths to give them body.
Oh, I see. Then they set up a second auxiliary track with a clean Bucket Brigade Boss DM2 model solely for the mid-range percussive elements, keeping the rhythm incredibly tight.
And finally, a third auxiliary track running a massive wobbly roll-in space echo strictly for the high-frequency leads and cymbals to add atmospheric shimmer.
That is wild. Every frequency range gets its own tailored vintage acoustic environment.
The result is a mix that is fiercely clean, yet wildly three-dimensional.
Okay, let's unpack this. So what does this all mean for you? Well, whether you are sitting in a dimly lit studio trying to mix the next underground tech house banger, or you are just listening to your favorite playlist on your morning commute, you now understand a foundational truth about modern audio.
The curtain has been pulled back.
It really has. The incredible depth you are hearing, that immersive three-dimensional space, it isn't an accident. It is the deliberate, masterful orchestration of vintage imperfections.
Imperfections that are completely intentional.
Yeah. It is the careful application of, wow, flutter, tape hiss, and analog capacitor leaks, all perfectly calibrated to hack your brain's evolutionary psychology and make you hear a massive acoustic space. As the 786 Music Notebook concludes, the vibe is the only rule.
The vibe truly governs everything. But, analyzing how we manufacture that vibe leaves us with a fascinating paradox to consider. We just spent this entire session exploring how Echo Boy, a mathematically pristine marvel of modern coding, was explicitly built to emulate the broken motors, hissing tape, and physical flaws of 1950s hardware.
Right.
It makes you wonder, 50 years from now, when audio technology is unimaginably advanced and perhaps driven entirely by neural networks, what digital flaws or coding artifacts from today's pristine software will the producers of the future be nostalgically trying to emulate just to make their music sound human again?